I'm Gene Norman, Chief Meteorologist here at KHOU TV, and I'm excited about the prospect of snow anytime we might have snow in Houston. It is pretty rare though, and one of the reasons for that, of course, is because, well, it just doesn't get that cold here in Houston. Now, of course, we're living right next to a big source of moisture, so that's always helpful when you want to create snow, but you need other ingredients to make the snow. Because up in the atmosphere, temperatures are below zero, let's say around 10, 12,000 feet. But if the temperatures are below zero all the way down to the ground, any moisture that's in that cloud is going to freeze and fall back to the ground as snow or ice. Objects reflect the light that shines on them. That's the reason why, for instance, a banana looks yellow, because it reflects back all the wavelengths except yellow, so you see yellow. In the same way, the snowflake is composed of ice crystals and air molecules, and depending on the space between the air molecules and the ice crystals, more of that will be reflected back. In the case of snow, it's all reflected back, which is why it appears white. Well, up close, depending on the temperature, snowflakes can take one of several different forms, and it's really important to know what the temperature is, because that'll determine whether or not you have hexagonal crystals, or you have needles, or you have the more common what are called dendrites, six-sided pointed ice crystals, and that's what we typically see as a snowflake. Different ranges of temperature causes the ice to freeze in a certain way, and it causes that crystal to form in a certain shape. How big they are could depend on how many collisions they go through as they go up into the cloud and then come back down to the ground, because those particles, as they're rising up within the cloud, are colliding with other particles, both on the way up and on the way down. And then there's also some melting that occurs as that ice crystal falls back down to the ground. So that's why you may have different size ice crystals and snowflakes as they fall. It is pretty much true that snowflakes don't all look identical, that they are very, very different because of those nuances in the way those crystals connect. Because it's kind of neat. It's kind of exciting, and if it occurs around the holidays, it puts people in kind of a very jolly mood, a very happy mood, a very lighthearted mood, unless you have to shovel it. Now, I grew up in New York, and it wasn't a lot of fun when we got into January and February and you're shoveling all that snow out of your driveway. Down here, it's more of a novelty because it's kind of exciting. Kids love it because school is closed. So I think that's why people just get excited. It's a big change. It's something really out of the ordinary. We don't get snow that often here in the Houston area. It's so rare that when it does occur, it really causes a level of excitement. If the conditions are right, we might. And yes, kids, it's possible we could even have a repeat of 2004 and another white Christmas. But it is possible because we have to have the timing of those two events just right. The moisture arriving at the same time the cold air arrives. Sometimes you might get one but not the other. You have to get both exactly right at the same time. It's a tricky forecast and something that we'll be watching for this winter.
How Snow is Formed by Anna Newhorter-Button, Lindsay Durdall, and Alyssa Strickland. This short film is to inform students about snow.
Snow begins in the sky as water forms into a tiny droplet. As more and more water vapors form onto its surface, the droplet grows. Cold air then freezes this water into an ice crystal. Each ice crystal has a unique shape that depends on the surrounding air's temperature and water vapor content. If it is below freezing and there is a lot of water vapor in the air, the crystal grows 6 evenly spaced branches. More and more water vapor collects on these branches and freezes, making the ice crystal increasingly heavy. Eventually, the ice crystal falls from the sky, leaving the cloud of precipitation that it helped to form. As it falls, the crystal continues to grow by picking up more water vapor. As it descends, the ice crystal can come into contact with warmer air that makes it start to melt a little. This melting acts like a glue, causing crystals to bond together into larger flakes, forming what many people think of as the classic fluffy snowflake.